Okay, this question says, what is the mass contained in 5.6 dm cube of oxygen gas? This is simply talking about mass to volume relationship. That's stoichiometry. Mass to volume relationship. They are trying to tell you is how many mass will be present in 5.6 dm cube of oxygen gas. Then you now ask yourself, what is the mass present in the molar volume, which is 22.4 dm cube? Now, one thing you should know is 1 mole of oxygen will contain 22.4 dm cube. Then in terms of mass, 1 mole of oxygen gas, how many mass does it contain? One oxygen atom is what? 16. Two oxygen atoms with what? 32. This is 16 here. So 16 times 2 is what? 32. So 1 mole of oxygen gas is still 32 grams. That's what it contains. That's why they call it gram per mole. That's the molar mass. You understand? The molar mass of oxygen gas is 32 grams. That's present in 1 mole. That means for every 32 grams of oxygen, there's 22.4 dm cube there, the volume. So there's 32 grams present in 22.4 dm cube of oxygen. You understand? So they're not trying to tell us what is the mass that is now present in 5.6 dm cube. If 32 grams is present in 22.4 dm cube, how many will be present in 5.6 dm cube? It's simple. You understand? It's very simple. What we just have to do is put 5.6 dm cube here, put x gram here, then you cross multiply. When we cross multiply, it's going to be what? All right, 22.4 xg. Remember, xg is the unknown gram we are looking for. 32 times 5.6 is 179.2. Divide both sides by 22.4. It's now going to give us what? 8.0 grams. Now, what this thing means is that there's approximately 8 grams of oxygen gas present in 5.6 dm cube of the gas. Same way, there's 32 grams of oxygen gas present in 22.4 dm cube of the gas. This is mass to volume relationship. We also have mole to volume relationship, mole to mass relationship. You understand? This is the sweet thing about stoichiometry. You understand? You know, in the earlier one we solved, it was mass to volume relationship. We can now solve it too in mole to volume relationship. Like I said, 1 mole of oxygen gas to be specific, contain 22.4 dm cube of the gas. Then how many mole will be present in 5.6 dm cube? You cross multiply. I too like this cross multiply. You cross multiply. Is that going to be what? 22.4 dm, 22.4 x mole, because we are looking for x, equals to 5.6 times 1, which is what? 5.6. Divide both sides by 22.4. X mole, let's check. 5.6 divided by 22.4. It's now 0.25. So for every 1 mole of oxygen gas, there's 22.4 dm cube. Then for 5.6 dm cube of oxygen gas, there's 0.25 moles. Do you understand? So if you multiply this 0.25 moles to 32 grams, you're going to get 8 grams to match what we earlier solved when we solved mass to volume relationship. Thank you.